Hey guys, today's lesson is going to be on the scientific method. It's a wonderful way to begin the year in chemistry, as a scientific method is a process scientists have used over the course of history to answer their questions. And you're going to find out it's a way that we use every day to answer our own questions too. So it should be familiar to us in the fact that we've seen it already, but also familiar to us that we probably have seen it before in our previous sciences. If I was to define the scientific method, I kind of start out by saying it's a systematic process. Systematic meaning we have one step that follows another step that follows another step. And it's a systematic process that scientists use to answer their questions and also to do research. Okay? You have to figure, all the stuff that we know about anything in science so far has either been learned by someone asking a question or learned by someone actually stumbling upon something by accident. And even when that happens, we still have to go back and ask the questions of why this happened. So it's a systematic process, that's the key, meaning there's steps involved that we have used to answer pretty much all of our questions. Early on, what are some of these early scientific discoveries that scientists had to ask questions about? We all know Isaac Newton, the famous apple was falling, and he said, wow, all things fall. And the question was, why do things fall? I have observed the apple falling. I observe other things falling. Things don't fall upwards. They all fall downwards. So we have to answer these questions, and that is something he actually answered. Some early explorers, they kind of said, oh my gosh, these boats, when they go over the horizon, they're disappearing. Once again, you're going to notice that I started this off with, they observed that the boats disappear. So you see two things here, observing the apple, observing the boats. We're making observations. We're trying to answer or ask questions about these observations. We asked this question, does the sun really orbit the earth as the early, people actually thought, or does the earth orbit the sun? And so we see these, these thoughts going on. It might not always be, I observe this. It also might just be asking a question too. So the sun may not orbit the earth. And once you lay that train of thought down, you have to have a systematic process to test it out, to see if it is true. Under daily observations, you're going to say, man, I'm tired, man, I'm thirsty. And you're going to go through these processes of why, Am I tired because it's allergy season? Am I tired just because I didn't get enough sleep? Am I tired because I went to football practice all day? Why am I thirsty? Is it the medication that I'm taking? Was it that super salty pizza that I ate? You might even say, hey, I'm failing chemistry. This is an observation. Why am I failing chemistry? What is it in this class that I'm stumbling on? Just recently, my check engine light came on in my car. That's an observation I made. And now my mechanic is going to have to go through the scientific method to find out why the check engine light is on. The steps that are involved in this systematic process are kind of key. And there's steps that you and I make, use when we actually say, hey, man, the light bulb, the light is not working. What's my hypothesis? What's the experiment I'm going to use? These are the steps in the system that we're going to use to answer our questions. It all starts out with that observation. I'm going to observe something of scientific interest. And like I just said, man, hey, my computer's not working. That's an observation you and I might make in our everyday life. The lawnmower won't start. My boyfriend or girlfriend won't talk to me. I noticed that my sibling is mad. These are observations that you and I make. We're observing something. In this case, in our class, it's of scientific interest. So we're going to focus kind of on our class here. What is it of scientific interest that we're looking at? When you follow in the system of thoughts, an observation is then going to go into a hypothesis. You're going to try to explain that observation. Okay? So you observe something, awesome. Now we're going to make an explanation for that observation. You're going to follow it up with some experiments that would test out your hypothesis. And then lastly, you're going to make a theory or conclusion. Now here's the thing. All right? Here is the thing. When we're doing this, you might say, I have an experiment to test, and one of the things I want to impress upon you is you have to actually retest the hypothesis. The experiment needs to be done a few times. Okay? Anytime you make an experiment, the first experiment might not be right. And so you want to make sure you retest your experiment to make sure that the theory or conclusion you get ultimately, you end up with this, all right? This is what's known as a theory. So anything that we know as a theory, like the Big Bang Theory, the theory of evolution, etc., anything with the name theory after it is what we say is a thoroughly tested, okay? Many, many tests, that means many, many experiments have been done to try to explain why we get these results. Okay, so once again, you start off with number one by making an observation. Awesome, I observed something of scientific interest. Let me just take this, my computer doesn't work, example. The computer doesn't work. Hypothesis, okay, maybe it's unplugged. Check, is it plugged in? Unplug it, replug it in. When you do that, you're actually doing an experiment. Is it the plug? Hypothesis. Plugging it in is the experiment. Unplugging it and replugging it several times, you're testing your hypothesis. When you find out that that experiment doesn't actually, cause the problem in this case, you then go back to make your hypothesis. You're going to do another hypothesis now. Maybe it's the RAM in the computer. I don't know. So you take out the RAM and re-put a new RAM. You're doing another experiment, and you would do that several times. Okay? And lastly, you would try something else. Okay, what could it be? Maybe the monitor wasn't plugged in. And that's a separate hypothesis. Now we go back and test that. And then you find out, it looks like the monitor was not plugged in. So you take it out and the computer starts again. You take it out and you plug it back in again. And you do this several times. Ultimately, you and I would come to the conclusion, in this case, that the reason why the computer wasn't working was because the monitor was not plugged in well. And that ends up as our theory conclusion. The difference, though, is that in science, in our class, in our field of study, is that we usually say that it's a thoroughly tested explanation of why experiments give results, but there's a little, disclaimer here, is that any theory can technically be disproved or improved, and that the theory isn't like the end of the line. All right? If it can be disproved or improved, that gives us another reason to continue working on that. So in this case, once again, the scientific method deals with an observation. We make a hypothesis, we test that hypothesis with an experiment, and ultimately we come to what's known as a theory or conclusion. Okay guys, let's check this out here. Which of these is an observation? Just a little test, alright? What I would recommend you would do right now is maybe press the pause button. You can read these on your own and come back and say which one I said the observation was, okay? So maybe the bus was probably early today. Is that an observation? Or the bus didn't pick me up? The bus was actually early because my neighbor saw the bus come early. Tomorrow, I will come to the bus stop early to see if the bus comes early. So please take a second, which of these is your observation? The observation for us, this one, was number 2. You observed that the bus didn't pick you up today. That was your observation. The rest of these, might sound tempting, but they're really not an observation that you made here. Let's check out the next one, guys. Same way here. Which of these is the hypothesis? Is it that the bus was probably early today? Is it the bus didn't pick me up? Is it the bus was actually early because my neighbor saw it come early, and tomorrow I will come to the bus stop early to see if the bus comes early? Which one of these would you say is a hypothesis? Remember, hypothesis is going to be a proposed explanation for your observation. So press pause, check it out. I'll come back with the answer in a second. I'm going to have to say the bus didn't pick me up was your observation, so that can't be in there. Okay, let's just eliminate that one first here. I'm going to say the hypothesis, the proposed reason the bus didn't pick me up was that the bus probably came early. Okay, these other ones do not fall into the category of a hypothesis. All right, they're not a proposed explanation. Okay, just read them carefully. You should probably pick it out which ones are which. Well, check this out here, guys. Which one's the experiment? Well, we know these two are already used, so we can't use these two. So now we're down to 2 here. Which one is the experiment? Is it either the bus was actually early because my neighbors saw the bus come early, or was tomorrow I'm going to test my hypothesis by coming to the bus stop early to see if the bus comes early? And you remember, the experiment, the whole goal here is to test that proposed explanation. Now, you proposed a second ago that the bus was probably early, so now you have to test that out. The one that actually tries to test that out is you coming to the bus stop early to see if the bus is actually going to meet you there early. That's how you're going to test it out. And lastly here, obviously, I think we're down to the last choice here. We've used this one, we've used this one, we've used this one. What is the final theory? What is the proposed explanation for my experiment gives results? Okay, and the proposed theory for this, okay, once again, your observation was the bus didn't pick me up. What is our best theory or conclusion about this? It's that the bus actually was early because my neighbor actually saw it come early too. So you probably went there and you did an experiment and you said, yes, the bus came and picked me up early. In the choices that I have given you here, though, the bus was actually early because my neighbor saw it come early. That's going to yield some information for us. It's going to give us some valuable data that we can use in our scientific method. So the whole goal of this is to try to pose an explanation for what your observation was giving you. Okay? In this case, we're simply saying the bus came early. Could you refine this? I bet you could. I bet you could come up with a better reason why that bus was early, actually. Okay? And maybe it had a flat tire. Or maybe that's just the driver is driving slowly. So you could probably improve this as well. The goal of this lesson was to introduce you to the scientific method and all the steps involved. I do want you to see that it was a systematic process that got us to this point. It's something that scientists use and that we use in our everyday life. Thanks a lot for tuning in, guys. Have a good day.